How's everybody doing? We actually made this on purpose. We want you to be anticipating this very, very much. You guys have picked the best room. This is going to be a great one. If I can introduce to you guys, Todd Groten.
All right. Thank you, thank you. All right. All these Call of Duty fans. Actually, can I have a show of hands? Actually, who knows what Call of Duty Elite is? Very good. All right. Cool. Well, I represent Activision Blizzard. I work at the Beachhead Studio, and I work on the Call of Duty Elite product. It's a tie-in between all the different Call of Duty titles, starting with the beta we had in Black Ops, and launching with Modern Warfare 3, and moving on to the next one we're launching in November, Black Ops 2. So here's all the legal mumbo jumbo that they approve me to say, but hey, whatever. So Call of Duty Elite is a web service that's a social network, a competition site, and a site for improving your game. It has many different pieces. We have a compete section for what we call clan operations and groups. They are different areas for bunches of people to get together, play the game together, and win either virtual badging or, in our we call Lone Wolf operations, tangible stuff. In fact, we've given away, I think, 3 or 4 Jeeps already, trips to France, snowmobiles. So it's actually a pretty cool little product here. It's an add-on, for all the Call of Duty titles. We also have sections in there for improving your game. So we have areas to improve your weapons skills, to let you know what the best build-outs are, what the types of attachments you should be using, different maps are in there to know where the best kill areas are, where you can kind of camp from if you're a sniper, which is actually my area of expertise. I tend to be the sniper, not the run and gun type. And really to get to know the game in a lot deeper than just playing it and getting kicked. This will actually help you improve a lot. I went through it personally when I started playing Black Ops, and just by knowledge of the maps alone, improved my game like about 5-fold. So when we launched faster than Xbox Live, Netflix, and Hulu combined. It took them 1 year to get to 1 million users. We did it in 1 month. We also are the fastest growing or grossing game out there. We beat the Avatar property, where they did $1 billion in sales in 17 days. We did it in 16 days. So it's quite popular. And actually, as of August, we're over 10 million or 12 million users. And with that, we have about 3 million subscribers. Although people get into the whole thing, well, is it a pay site? No, it's not a pay site. But with that, you get a bunch of the downloadable content if you do subscribe. You get you get a bunch of the different pieces of the site for free, like the clan operations and the approved videos, and some of the other features, like Elite TV, which was actually kind of a cool idea. We have different web episode shows that we've produced. There's a new one that we've put out called Cocked Hammers that has Will Arnett and Jason Bateman, where they've actually been put into the game. It's got a little, 10-minute episode series. And we have other ones that are, called Friday Night Fights. We have 2 different types of groups come together and battle it out for a big, huge, like WWF type belt and some prize money. So, rockers versus rappers, or policemen versus firemen. Even the the best clan of one area versus the best clan of the West Coast versus East Coast. So there's a lot of different rich content that we provide. Well, with that, we have quite a need to scale this thing up with 12 million users wanting to hit the site at any one time. And because we're deployed entirely in the cloud, we can't really control how the servers that are behind the scenes are running hot or running cold without having some pretty decent monitoring. What we found that we had a problem with dynamically scaling our servers and adding monitoring. When we first were running the beta, we had some problems with spinning up and spinning down servers that really kind of made me a bit running ragged. We had one area that we went to. We had a product that we used. Actually, both used Hyperic and Zabbix for it. We ended up with hundreds and hundreds of dead servers as things spun down that didn't get deleted from Nagios. So we needed to have some sort of dynamic adding of the monitoring and deleting of the monitoring when the server went down. When we go up in threshold, we have a set, we'll go up by 50 servers, 100 servers, or our web service, maybe 200 servers. But when we start spinning down things after like a clan operation, well, we'll only go down by maybe 10, 20 at a time at each interval. Well, if you do that enough, you're going to get a lot of servers that aren't being monitored, and you'd never know truly where your CPU cycles are being serviced. And so when we went and had over 900 stale servers, it wasn't trivial to remove those from the database from the other products. It took me several hours to do, and that was only after maybe a day or two of servicing users. So I knew that was going to be a huge problem for us. So we actually analyzed a bunch of different products for that and found Nagios was the best to do all of that. It was the most extensible, and we could take a look through the back-end services like Nagios SQL and determine that there was a way to scale everything up dynamically. So what we found was Nagios was great about putting servers in if you knew the subnet that they're on. Well, unfortunately, in our public cloud, we found that you can't quite auto-scan a 10 dot. They wouldn't allow that. Because being in that in the public cloud that we are, they have reusable server IPs for everyone. So that 10 dot really spans all of their tenants on that server and in that infrastructure. So using the auto discovery features of Nagios was not an option. But what we did have was in XI we had the configuration files, and the configuration files were adequate for a while. But then we started spinning up the multitudes of servers, and we couldn't quite deploy them out as fast as we wanted. So we started looking for alternatives, and we found the bulk import host wizard. And we could actually write a script, and with the script, we could create a common delimited list based on a cron job, and then manually every cycle, every hour or so, go in and push for that common delimited list to be added to the bulk import host wizard and use the template that we've created for each of the servers. Well, that worked for a while. It worked for probably, a couple months. However, when we start spinning up and spinning down servers at 50 or 100 or 200, well, adding that in we found was slower than the rate of the servers when they automatically started scaling. When we turned on auto scale, when the servers wanted to do it themselves, we didn't have anyone behind the scenes to actually go and grab that at that time in real time. And so we lost probably a good 2-3 hours of monitoring on those servers that we could know how is the server performing, how is the web service performing, how is the thrift services, the Java, the PHP, everything that we needed to monitor for that server to determine the health of the site and each piece of that site. Well, we found that the next piece, the next area that we wanted to go to was straight to the configuration files. So we had an auto deployment strategy using a couple different tools out there like Chef and RightScale. We even dabbled in Puppet a little bit, but we found with Chef it was the easiest to implement the multiple configurations. We would simply have a server start spinning up, determine what it is, then go out to the repository, pull in the correct configurations, and then dump them over to the import folder on the Nagios server. Then we did a reconfigure and they would be monitored. Hey, that worked perfect. However, we didn't have the ability to create one file. We had to do it in multiple files for that, which was okay. It worked. But then once we got into the removing of the servers, well, that was where we had a big issue, because we couldn't find anything in any documentation anywhere that said this is really what you need to do to remove servers dynamically. I mean, sure, Nagios put together adding servers, the bulk import host, the auto discovery and all that, but didn't really have anything that really grabbed it to pull things out very easily. So we started digging into the core system or the XI scripts area, and we found the scripts that actually controlled all of that. Well, one thing led to another, and we actually went through and coded a piece of the system to go out and query Nagios SQL, pull back all of the IDs, loop through for whatever the server name that we've added to it, and put it into an array, loop through that array, and do a delete services on each of the services, and then go and do a delete hosts on each of the hosts, and then do a reconfigure to remove it. And that worked perfect. So we could actually bring up and bring down hundreds of servers without having to worry about them losing any information, any of the performance metrics that we needed, or getting added and creating dead hosts in the database. The only problem that we found with doing that was there was a race condition when you started bringing down things at the exact same time. So we had to put together something, we had to figure it out that if we enabled files in a folder with the server name and created a parser to say, okay, is that server, has it been removed or not? Then we were able to correctly determine if the parser needed to run, and then the poller did a reconfigure. The simplest way was to actually create a file with the extension of a .done. So once it's been imported, once it's set into monitoring, then it creates a file, and then once it's ready to be removed, the Chef client or the RightScale client on a decommission script will go in and rename the file .done after it removes itself from monitoring. Then, in one big bulk move, once the poller has gone through the directory on every minute, an interval of every minute, once it saw all the .dones, it would then initiate the reconfigure Nagios. And that finally fixed all the problems that we had with dynamically scaling this. So we have currently up over several thousand servers, and not worrying about anything coming or leaving the monitoring system without being gated at the monitoring installation. So, yeah. After all of the trials and tribulations of adding and monitoring, now we had to go through and determine services, and that was kind of trivial in one respect, because we could add the hosts and we could add services separately, but they tended to get out of sync. So what we found, actually, after I ran this by Mike Guthrie and say, hey, we're going to break anything we're doing this? And he came back, no, it actually looks pretty good. We went through and did some modifications to that, where we would pull in a little bit of additional data and make sure that things are properly categorized into the proper host groups and service groups. A couple weeks later, it was the code that we wrote was improved upon a little bit by the Nagios team, and they finally solved the one area that we really needed, which was the importing of the services and hosts into the one file. At that point, we simply set up a role. We set up the recipes to go put and concatenate this one file together, shoot that over to Nagios, SSH in and it do the import, and then do the reconfigure to pop it, and everything was perfect in the host file and the services file, and everything. It was wonderful. I'm going a little fast there. Okay, so the last part of that is after we had the combined services and hosts into one file, the other piece that was really a blessing in disguise was the rewrite of our experimental code to include the config name, as opposed to having to parse through the database by ourselves and look at Nagios SQL and do a lot of the things that were a little more processor intensive for Nagios to do. The newest automation that's built into 3.2 includes our code, but it improves upon it with all you need to do is put a -- config with the service name, or service name, but the server name that you put into, that you installed with Nagios, and it does it all for you. So this is how the architecture looks today. This is what we have been working on, and after all of these automated deployments, this is what finally came up with for performing the best with thousands of servers being monitored in a dynamic fashion. Each thing is isolated to a zone. Each Nagios server is isolated to a zone in the public cloud, and that provides redundancy. If a cloud or the availability zone goes down, each of the Nagios servers are tuned for a particular type of service that they provide. So we have a statistics server with Graphite and StatsD. We've got one dedicated to pulling base metrics. With our right scale, we got collectD for free, so we start pulling in the collectD metrics and operating off the thresholds there. We had different MySQL checks that had to operate with our leaderboard scraping. And then we had different areas that weren't quite zone related, weren't quite infrastructure related, and those ones were the overarching areas, like our daemonware, middleware pieces that need to be monitored. Certain profanity filters need to be monitored, otherwise people could get in there and swear, and Xbox didn't like that. So We also had areas for SSO and our umbrella services. Those needed special handling, and so whenever we brought up a server that had that piece on there, we had to tag it with that particular Nagios instance. Then we also had one dedicated to all the web checks, which was fairly static, but it also, if we were bringing up a particular type of service, like a new clan challenge, we had to have a new check that was automated or automatically added to the JMeter and web inject section. Then all of that was managed by Fusion, which was pretty cool, and it did its job. But the primary meat for all this, the primary servers that went through were the root management servers, and they handled all of the checks with Mod Gearman and distributing the checks against all the availability zones. So we created a fairly high availability infrastructure that could dynamically scale with all of the services and hosts that we needed to add at one time. Oh. All right. Are there any questions?
Thanks. Hello. Okay. So I'm not familiar with the XI product.
Okay.
You talked about the reconfigure process, though.
Mm-hmm.
Is that doing a reload behind the scenes, doing imports of whatever it's doing, and then actually reloading the Nagios daemons?
Yes. Yeah. Behind the scenes, it's doing a reload all the services, contact groups, service groups, host groups, everything back into the system, into Nagios SQL, pulling it over to Nagios, and then pushing it down to the config files.
So what I was getting at is, so the daemon itself is actually doing a reload.
Yes.
So, okay. So you haven't run into issues with reloading it so often like that, like dropping services or losing scheduling or anything like that?
We did, and that's why we had that race condition. When we were dropping 200 servers, yes, we could definitely run into that. If one server was getting reconfigured at the same time that another one comes in and tries to initiate a reconfigure again, then yeah, it would drop the first server. So we had to build in a poller to take care of that. So if once it's gone through and says, okay, every single server it needs to be checked as the dot done, now you can do the reconfigure in one shot.
So how often do you do the reloads on average?
It depends, but probably when we're doing the bulk of the removals, about every 5 to 10 minutes. It really depends on Chef or RightScale coming in and actually decomming, because you have 100 seconds to get it out there and get that reconfigure done before the server terminates.
Wow. Oh, that's very interesting then. I haven't had the same experience with being able to reload so often. Like, I'll just drop services, independent of the loading configs and things like that. When you reload, all the pipes get dropped and all of that, right? So I've just had issues behind the scenes with that. So we have to really limit and control how often we're kicking the daemon, either by a restart or a reload.
Well, like I said, what I found is we had that race condition, we had to create a poller on our own. It may be something you want to try.
Yeah. Okay. Thank you.
Sure. Any other questions?
With it restarting so often, how did you get any monitoring done? I mean,
well, it was a little difficult at first to get used to the servers spinning up and spinning down so often. But once we found the correct balance, we found that the servers didn't want to spin down all that often, and it was a lot easier to go and take a look at any gaps that may have been from a server that was previously started and just happens to be 5 minutes later when it's shut down. So once we got stabilized, we would get an hour or two worth of data, or if we were running a clan operation or some other event that would drive people to the site, would force an up or a down scale, then that's when we do see that, and we see a lot more gaps. But for the most part, the monitoring does get in pretty steady.
So did you ever look at doing sort of like some clustering or high availability so that you could have maybe one restarting and then, you know, do the next one as well? Sort of.
We did look at that, but we had to look outside of Nagios for some of that, and we found that the other products could do a lot of the auto registration and auto discovery better, but they still had that problem with the downscale, and it wasn't feasible for us to do this.
Cool, thanks.
Mm-hmm.
So I have two things, and I hope the first one's pretty quick. You said when you're bringing machines in, you're adding services for those machines. So is that through literally adding individual services, or is that through service groups or host groups that are sort of catching generic blankets of machines that are coming in?
Because each type of server that we runs different services and different configurations of each service, we actually found that we had to create a service file for each thing. So we were adding a fresh service in, not just using a template that got filtered down.
Okay. And the second thing is, what would you do when you decommission a machine? What happens to its history as far as what Nagios sees? I'm assuming you need to run reports to see where your CPUs are going and CPU cycles are being used and things like that. So over time, you're going to have thousands of phantom machines in your reporting. So can you kind of expand a little bit on what happens there?
Sure. Well, let me go back a slide here. So with the StatsD and Graphite server and the collectD metrics, all of the metrics from the individual machines were being stored in the performance area of Nagios, being pulled up into whatever zone it was, but they're also shipped off to specific StatsD and Graphite servers. So we may be monitoring, or we may be duplicating some of the performance metrics, but with Graphite and StatsD and the Carbon, we were able to carry over the history and roll things up. So you have the concept of a star level in Graphite. So as it goes into servers, then it will pull in all the servers that are there and all the servers that have been there. And you just look at a time frame, and within the time frame, you'll find servers added and removed, but you'll get that trend line.
So you're doing your reporting is really done then out of Graphite, not out of Nagios?
Correct.
Okay, thanks.
Anyone else?
Any additional questions? Perfect.
This is not so much a question, Todd. It's just saying we certainly appreciate your help. I know talking with Mike Guthrie and the guys in our team, your use of Nagios XI certainly pushed our product to its limits, and we were happy to get some feedback from you to help improve that. One feature that it has not yet been released for Nagios XI is something called the dead pool, which may help with decommissioned hosts and services in the future. It's a feature that will, if a host or service is detected as being down over a certain period of time, it'll automatically get deleted from the system, so periodically. So that's something that also may help in the future as well.
Well, that is something that we were looking for when we were evaluating the other products, and they really didn't do a very good job of it. Yeah, there you go. That would be awesome to see that. We typically do have hosts that may be offline for a day or two if we're running maintenance, but if something happens and it actually doesn't remove itself, that would be a terrific feature to have.
Can you talk real quickly about a little bit more about your metrics integration between?
Sorry, that mic is really gone low.
I was interested in knowing a little bit more about your metrics integration between the various metrics collection and polling tools you have in Nagios. It sounded like you were going. I'm used to hearing people using Nagios as a poller for Graphite. I'm not quite sure I understand what you guys seem to be going the other direction.
Well, initially we started to push stuff into Nagios and run behind the scenes with the RRD stuff. it just didn't work for us when we started spinning down servers, and things did get a little wonky with all the files. We found that the directory for all of those files was getting a little full. So we actually decided to offload all of the metrics gathering, except for certain application level metrics, to go to Nagios. We offloaded that to separate services. I mean, you could do this probably with Graphite. Cacti, but we found Graphite was the easiest to run with the carbon collector, and pushing it out of Nagios, it divides itself. On each server, we have a configuration that one goes to the Nagios server to push everything via the check-in, the plugins, and then we have another process that pushes it off to the Carbon server for collection. We found that it doesn't really double the bandwidth. It's just a blip. So we could survive on hundreds or thousands of connections to the Graphite server and adding the metrics directly to it, as opposed to having it pull from Nagios. So that's really where we're going with that. We do the direct metrics push over to Graphite.
So I guess really I'm just asking, like, so what does the dotted line between the Nagios server and the Graphite server represent then?
I would say the dotted line between the two, anything that has to deal with application monitoring, anything that deals with alerts that are not specifically infrastructure based, that kind of trending goes over to the Nagios system. Anything that is trending based, that we have to take a look at the history of the service as a whole, that gets pushed over to Graphite. And some of the other systems we have behind the scenes, but Graphite's our primary one. So the applications, they may be all of the Java services that are servicing a clan operation, or it might be the PHP pushing over the web service layer, but not, say, CPU cycles or memory or disk space. Any of the base metrics, they'll get pushed the other way. Anything else?
Todd, I had a quick question. So your monitoring infrastructure itself, is that primarily static, or are you also dynamically spinning up like Mod Gearman workers as needed?
Actually, we are. We just implemented that about 2 weeks ago.
And do those get spun up via right scale images, or?
Well, currently right scale, but we're moving toward those out towards Chef, since we're in right scale now, and it's really just kind of Chef on crack. We're moving directly to Chef to get rid of the crack.
Excellent. Thank you.
Any other additional questions? All right, well, I have a feeling we got a crowd favorite. Ladies and gentlemen, put your hands together for Todd Groten.